Hi, welcome to the video solution for past paper. This is Edexcel IAL Mathematics paper M1, January 2020. So let's start. Question number 1. Two particles P and Q of mass M1 and M2 respectively are moving on a smooth horizontal plane. The particles are moving towards each other in opposite directions along the same straight line when they collide directly. Immediately before the collision, both particles are moving with the speed u. So scenario is we have two particles of masses m1 and m2 moving towards each other in opposite direction. So we have particle P, maybe this one with mass m1, particle P, and particle Q, let's see this one, and mass m2 of course, and they are moving in opposite direction towards each other, so with the same speed. Remember, they have a same speed, so these are initial velocities. So initial velocity of both particles are the same, which is u and u. So and they collide, so that means these particles are of course going to collide, particle P and Q, and there will be a collision in between. The direction of motion of each particle is reversed by collision. So after collision, both the particles moves in reversed direction. So particle P is coming back, particle P, and particle Q is going in that direction. Immediately after the collision, the speed of Q is 1/3 of u. So speed of Q is 1/3 of u. Find in terms of m2 and u the magnitude of impulse exerted by P on Q, impulse on Q in the collision. Remember, these are typical questions come in exam from M1 paper. So especially in momentum, the important thing is you need to take care of the direction of the motion, because we are talking about momentum, we are talking about impulse. All these are vector quantities, so they have directions. So it's your choice whether you take rightward as a positive direction. That means the negative direction will be, sorry, the leftward direction will be negative. Or if you wish, you can choose vice versa. I mean, if you wish, you can choose rightward direction as negative, so the leftward direction will be positive. So it's totally up to you. But what I generally do, because I know that the right side is taken as a positive x-axis, so I generally choose right direction as positive. So meaning when you draw the diagram, you must mention the sign of the velocity. So particle P is moving rightward before collision, so I'm going to take speed or velocity of P as a positive u initial, and but Q will be taken as negative. So meaning momentum of P I will take positive, and momentum of Q I will take negative momentum, minus m2u, something like this. And after collision, particle, because directions are reversed, so the velocity of particle Q will be taken as positive, and direction of velocity of P will be taken as negative. Let's suppose Vp, it is minus Vp. And now the question is, find in terms of m2 and u the magnitude of impulse exerted by P on Q. So we need to find impulse on Q. So remember, impulse is general concept of impulse is nothing but change in momentum. So mv minus mu, because we need to find impulse on Q, so we need to find change of momentum of Q. Change of momentum of Q. In this case, this should be the final momentum of particle Q and initial momentum of particle Q. So you can write final momentum of Q, which is, you can see that the final velocity is plus 1/3 of u, and mass is m2. So final momentum will be positive m2 1/3 of u. This is mv, momentum of final momentum of particle Q, and minus initial momentum of particle Q, and initial momentum of particle Q is taken as negative. So you can say that it should be minus M2U, and this minus minus becomes positive. So you can say that you have 1/3 of M2U plus M2U. Now you can simplify. You just multiply 3, so you say that the impulse is because this is 1/3, so this is 3 M2U, 3 M2U plus M2U, so 4 by 3 M2U. This is impulse on Q. You can write Q here. This is impulse on Q. Don't think that this is answer of B, okay? This is answer of A. So impulse on Q is 4/3 of M2U. Part B is find in terms of M1, M2 and U the speed of P immediately after the collision. So we need to find the speed of P. That means we need to figure out VP. And in this case, we have two choices. We can consider law of conservation of momentum. Conservation law of momentum, total momentum before collision equal to total momentum after collision, or because we have already found impulse. So we can use this impulse to figure out velocity of the P. The idea is we know that the impulse of P, I'll do here part B. So since impulse of P, IP would be equal to final momentum, again same concept, final momentum minus initial momentum, but it's all about particle P. So final momentum of particle P will be minus M1 Vp and minus initial momentum, and initial momentum will be, you can see, M1 U. So this is momentum of particle, impulse on particle P. And then you, because we need to find Vp, rearrange for Vp, so you can say that send M minus M1 P on the other side, so it becomes positive. M1 Vp is equal to minus Ip minus M1 U. And since impulse on P is equal to negative of impulse of Q, because impulses are in opposite direction. So impulse on P is as same as impulse on Q, but the direction will be opposite. So IP will be minus IQ. So you can substitute value. So M1 Vp is equal to minus of IP, and IP is minus IQ, and minus IQ will be minus 4/3 of M2U. So you can say that this is minus 4/3 of M2U and then minus M1U. And you just simplify this equation, so it will become minus minus positive. So 4/3 of M2U minus so 4/3 of M2U minus M1U. This is M1 Vp, and then you need to find Vp, divide by M1. So Vp would be equal to, divided by M1, so it will be 4/3 of M2U divided by M1, or 3M1 minus divided by M1, so which is U. And then you just take LCM 3M1. When you take LCM 3M1, so you can say that VP would be equal to 4 M2U minus 3 M1 U divided by M1, 3M1. And then you can leave it here, it's fine, it is also your answer. But if you wish, you can simplify more. You can take u common. If you take u common, so Vp would be equal to take u common, so 4 m2 minus 3 m1 divided by 3 m1 into u. So this is velocity of particle P after collision. You wish, you can leave your answer here. This is also acceptable. Part C is hence show that M2 is greater than 3/4 of M1. Clearly, because we have just one relation between masses M1 and M2, which is given by answer of part B, which is Vp equal to this. And we know that after collision, particle P will be moving with some speed. So we know that since, for part C, since Vp cannot be 0, and it should have some positive velocity, because see, we need to find the relation between masses, so there's no need for direction. So Vp should be positive. Magnitude of the velocity, or the magnitude of the speed of particle P should be positive. It cannot be 0. So you can say that for this equation, Vp cannot be 0. That means 4 m2 minus 3 m1 divided by 3 m1 should be more than 0. And now you have an inequality, and you solve, or you simplify this, you solve this inequality to make m2 as a subject. When you make m2 as a subject, so you can pause your video and then try to solve it for m2 and make m2 as a subject. So you will find that the m2, I'm not doing these steps here, I'm just leaving for you. So m2 would be greater than or more than 3/4 of m1. You should get this relation, which is the required one. Question number 2. A non-uniform beam AB has length 6 meter and weight W Newton. The beam is supported in equilibrium in a horizontal position by 2 vertical ropes, one attached to the beam at A and the other attached to the beam at C, where CB is 1.5 meter as shown in the figure. The center of mass of the beam is 2.625 meter from A. The rope are modeled as light string. The beam is modeled as a non-uniform rod. Given that the tension in the rope attached at C is 20 Newton greater than the tension in the rope attached at A, find the value of W. So first of all, in these types of question, remember these are again a typical question of a moment. So first you just visualize how many forces are acting in the system. You know that this is the beam, and it's not just it is not just uniform, it is a non-uniform beam. That means the weight of the beam will be acting at the center of mass, not at the center, it's somewhere else, and center of mass is 2.625 away from point A. That means 6 meter is total length, so the center 3 meter will be somewhere here. It will be, I guess, center. But so this is 6, that means this is 3. If this is 3, so 1.5 will be there, and then 2.5, 1.5 and 1 point. Okay, so I'll take here something like this. So this is the point center of mass. It looks, yeah, let's take here just for the safe side, just so you can just visualize. That means weight of the rod will be acting in that direction, which is W. That's what we need to find in part A. And other forces are tensions in the string, that at A and C. So tension always act in the string away from the point of contact. So we can say that this is tension in the string TA, and tension in the string as C is TC, acting upward. And that's it. These are three forces acting on this rod, W acting downward and TA and TC acting upward. We need to find value of W. So the idea is we are going to find the moment of the rod about either at C or A. It's your choice. You can choose any point as a pivot point, either A, B, or even you can take B as a pivot. But if you choose B as a pivot, then all the three forces will involve in the moment. It will be a little difficult to get rid of the forces. But if you choose C as a pivot, then you don't consider TC, because TC will be passing from the pivot, so TC will not produce any moment. Or if you choose A as a pivot, then you can ignore existence of TA, because TA cannot produce any moment. So I am considering moment of the rod at point A. So that means for when I'm going to write equation for moment, I'm not going to consider moment due to TA, because it is passing from A. So I can say that moment about A, or you can write taking A as a pivot. So moment about A. You know that if A is a pivot, then W is going to produce moment about this pivot in clockwise direction. So we have a moment of W in clockwise direction. Similarly, TC or tension will produce moment about A in anti-clockwise direction. And these are the only two moment in this system. So moment of W clockwise, moment of TC anti-clockwise. And according to principle of moment, because they are saying that the rod in a horizontal position, so both the moments are equal. So let's just write the equation of moment of W and TC. So clockwise moment is W times that distance. And this is one of the reasons that I chose A as a pivot, because this distance is already given, which is 2.625. So I can say that W force into moment arm or pivot distance, which is 2.625, which is this. This is clockwise moment, and it must be equal to anti-clockwise moment, and anti-clockwise moment is TC times that distance. We need this distance, and this distance, I know that this is 6 minus 1.5. So 6 minus 1.5 is the pivot distance for the force TC. So you can say that TC force into multiply by the moment arm or pivot distance, and this will be equal to 6 minus 1.5, which is equal to 4.5. And you can see that this is the equation that from which we can find W, which is our required quantity. But we have one problem, that we don't have TC. So let's just call this equation as equation number 1. We need to work out first for TC. And then for TC, they gave us one reference or one hint, that they are saying that the tension in the rope at C is 20 Newton greater than tension at A. That means TC will be equal to 20 plus TA, or TA plus 20, whatever suits you. Or you can say TA is TC minus 20. So both are a valid equation. So you can choose either this or this. Now we know that system is in equilibrium, and we have three forces. Two forces are acting upward, one force acting down. So we see the resolution of forces in vertical direction. So upward forces, sum of upward forces equal to sum of downward forces. So TA plus TC should be equal to W, the second principle of equilibrium, second condition of equilibrium. So TA plus TC is equal to W. Now you can replace TA with its value, TC minus 20. So you say that TC minus TC minus 20 plus TC is equal to W, and then 2TC is equal to W plus 20, and then TC is equal to W plus 20 divided by 2. This is the value of TC that we can replace in our equation number 1 to find out W. So you can write now equation number 1 implies that what is happening? 2.625 W, the left hand side, is equal to 4.5 times W plus 20 divided by 2, which is TC. So W plus 20 divided by 2. And now you know that you have equation only in W, so you should be able to solve this equation for W. So I am not solving again, I'm just giving you a chance to make W as a subject. You just first divide this 4.5, or you can cross multiply. It's your choice, whatever suits you. When you divide 2 with this, so you will have 2.25, and then 2.25 multiply by W first, and then 20 first, and then you rearrange for W, and then W you will find is 120 Newton. It should be 120 Newton. If you want me to do a complete solution, so please just let me know that whether you want each step. I don't think so, but if anyone wants, let me know that you want a complete solution in every step, so I will do in the next videos or whatever. So just let me know, please. So answer is W is equal to 120 Newton, or even if you think that no, this is fine, that I give you just idea, I give you equation, and then rest of the thing I just leave it on you. So whatever suits you, just let me know, please. I will be waiting for that. Okay, so this is the weight, 120 Newton. Now we have found weight. Part B, state how you have used the fact that the beam is modeled as a rod. A typical justified reason when you have you consider something as a rod, that means you are considering this object, no matter how big, how small, how thick the object is. If you are considering, or if you are assuming or modeling the object as a rod, that means you are assuming that this thing, this object is a rigid rod or rigid plank, whatever. That means there is no bending, it cannot bend. So that's what the meaning of model as a rod. So rod is a rigid object that does not bend. So that's how you can explain your assumption. Question number 3. A particle P is projected vertically upward with the speed u from a fixed point O. At the instant when P reaches at greatest height h above O, a second particle Q is projected with the speed half of u vertically upwards from O. Find h in terms of u and g. In this types of question, in my opinion, you should draw the condition, what is going on, so you can visualize the situation and you can apply the formula according to the condition. So what is happening here? We have a ground, and this ground is O, and we are projecting some particle P from the ground with the velocity u, initial velocity u, particle P, and this particle is going up, clearly decreasing velocity or speed, reaching at some maximum height. So this is the maximum height of particle, a maximum height of particle, and this height is given h. And what happened, as soon as the particle P reaches its greatest height, another particle Q at that moment is projected with half of the velocity. So we have another particle Q. As soon as it is reaching there, we are projecting another particle q with half of the velocity, half of u. So find h in terms of u and g. It's a straightforward question because we know that we are talking about total height and we are given condition or motion of particle p, initial velocity u, and it is reaching at greatest height. So at greatest height, final velocity of the particle p will be 0. So we can use third equation, which is v square is equal to, this is solution A, v square is equal to u square plus 2as. So v is 0, u square is of course u square plus 2, acceleration is minus g because it is moving upward. So acceleration is minus g, acceleration due to gravity, and s is the height or distance covered or height covered, which is h. And now you can rearrange for h. So h would be equal to u square or half of u square upon g. This is height in terms of u and g. That means this height is half of u square g. Find in terms of u and g the time between the instant when q is projected and the instant when the two particles collide. So you need to find the time difference. So when particles are colliding, that means time taken by the particle p and time taken by the particle q to collide, both the time will be same. So we can use, so what will be happening? You can just visualize that the particle p is coming down, something like this, because I just drew at a different position, but in reality the particle q will be projected exactly at the same position when the particle p is here. So you can imagine that they will be projecting particle q from here upward, something like this, and then particle p will be coming down, particle q will be going up. So we don't know where are these two particles colliding. So that's what first we need to figure out, particle the time. So time taken by the particle p and time taken by the particle q will be the same. So first we work out for particle p. So we know that this is for solution B. Distance of particle p, sp, let's say sp would be equal to because particle p is coming from there, so we are going to use sp is equal to ut plus half at square for particle p. And if you apply this, so at this condition here, initial velocity will be taken as 0. So u will be 0 because particle p is start falling down. So u will be 0. That means sp will be half of g t square. This is the equation for particle p. And for particle c also you can apply same rule for particle q. So sq, distance traveled by the particle q, s is equal to uq. Same equation I'm going to apply, but this initial velocity will be half of u into t, and because acceleration for particle q is going up, so it will be minus g. So minus half of g t squared. And the concept is because no matter what, where they are going to collide, so distance traveled by particle p, distance traveled by particle q, when they are going to collide, so and you add these two distances, so since sp plus sq, both sum of the both distance should be the total height. I'm just assuming, suppose if This is not the case, but just for your understanding, if this is the, suppose if this is the position where the particles are colliding, something like this. So distance traveled by the particle P, which is SP, suppose, and the height covered by the particle Q. This is SQ. Remember, this is not the case, but just for your understanding, why am I saying SP plus SQ equal to H? Because at the point of collision, this is SP and this is SQ. If you add these, so this should be H. Now, if suppose if they are if particles are colliding somewhere here, is this assumption? So this will be SQ and this will be SP, and some of these two will always be H. So it's all depends on the difference of the velocities where they are going to collide. So we will find soon. So SP plus SQ should be equal to H. That means you can say that SP is half of GT squared. This is SP plus SQ. SQ is half of UT minus half of GT squared. So half of UT minus half of GT squared is equal to H. And now half of GT square is gone. That means you can make T as a subject. So you say that you can make T as a subject. So half of UT is equal to H. And then T is equal to T is equal to what? 2H upon U. But if you read the question, find in terms of U and G. We found T in terms of H and U. So we need to replace value of H. So twice of 2 upon U into H. And H is half of U square over G. So half of U square over G. That means 2 and 2 gone. 1 U is gone from here. I'm sorry, this is again, this should be the same, capital U, because everywhere they give capital U. So finally, T would be equal to, it will be 2 gone, U gone, so U upon G. U over G. This is the time taken by the particle when they are colliding. Again, I did the whole derivation in great detail. If you think that you can skip some of the step, like you can skip this step if you wish, or you can directly put H here, so you can save some time. Okay, part C. Find where the two particles collide. So where are they going to collide? We need to find. So we have time when they are going to collide. So we substitute T either in equation for SQ or SP, and we can find the position where they are going to collide. But for me, it's SP equation is easy because of just one term here. So SP part C, SP distance traveled when the particle collide with Q, SP should be equal to half of G into T square, and T is U by G. So U square upon G square. So because of T square and T is U by G. So G and 1G cancel. So SP is equal to half of U square by G. And if you see half of U square by G, this is equal to H. You see here, this is H. That means when the particle is colliding, particle P is colliding with the particle Q, T equal to U by G, at time T equal to U by G, the particle P has covered the distance equal to h. That means particle has reached at the ground. So particle P is going to collide. P is going to, or is, is colliding, whatever, is going to collide with Q at O. O is the position, where the point of projection. So what will be happening here? That means particle Q will be moving up and particle P is falling down, and because of the half of the velocity, particle Q reaches at some maximum height and then falling down, and still particle P is following, and then they collide here. So this is the situation. Question number 4. Two identical small rings A and B, each of mass m, are threaded onto a rough horizontal wire. The rings are connected by a light inextensible string. A particle C of mass 3m is attached to the midpoint of this string. The particle C hangs in equilibrium below the wire with the angle BAC beta as shown in the figure 2. The tension in each of the parts AC and BC of the string is T. By considering particle C, find T in terms of M, G, and beta. So if you see, we have two rings here. Particle C is hanging mass 3m. Remember, ring A and ring B, they have mass. So we need to find T. Clearly, if you see the diagram, we are giving these two angles beta, 2m angle, beta, same angle. We have a triangle, so this should be isosceles triangle. That means the tension in both strings should be same, as they are saying. So T is in this direction and this T will be in this direction. And now we need to resolve T into its component. So for any of the rope, either for AC or BC, we can resolve T into component. So this is the normal one, and you can see that this blue one is a component of the T, and T is acting upward at point C. I'm referring at point C, so T is acting upward in that direction diagonally. So this component will have upward direction. Clearly, you see that if you resolve the vector into components, so this is the vertical component, and we have a horizontal component with reference to C in that direction, something like this. So this is the horizontal component. Clearly, you see you have a triangle. This will be T cos beta, which is adjacent component, and this will be T sine beta. And this is just for one triangle, and you can see another triangle here. So we have one more component of this T, which will be in the same, along the same T sine beta. So we have two T sine beta upward component. So you know that when you draw this component, so you can write as 2T sine beta is equal to downward force, and downward force is the weight of the C, which is 3 mg, which is W. If you remember, W is equal to mg, mass is 3m, so 3 mg, this is W. So 2T sine beta will be balancing W, that means 3 mg. And then clearly T would be equal to, because you need to find T, by find T in terms of mg and beta, so T would be equal to 3 mg divided by 2 sine beta. This is tension in the string, part A. B. Find in terms of M and G the magnitude of normal reactions between the wire and A. So the normal reaction, you know that we have a ring of mass M, and weight of the mass, weight of the each ring will be acting down. So we have WA and we have WB, and both weight would be same because masses are same, so it will be equal to mg, and this one also will be equal to mg. And then again, because weights are acting down, so at A and B we have normal reaction. So you can visualize normal reaction on A and B are upward, vertically upward. So you can say that we have RA and we have RB. Because we have isosceles triangle, all masses are same, A and B masses are same, WB equal to WA. That means RB must be equal to RA. So you can see forces in a vertical direction. You resolve forces in vertical direction. Just see the system as whole. See the whole system as whole. So you see what is happening. Just when you see a system as a one particle or one as a whole, so we ignore these strings. Okay, we are ignoring this string. That means on this beam, or if this is a roof, whatever it is a small wire threaded into horizontal. This is the wire. Okay, this is the wire. So how many forces are acting on the wire? So we say that vertically we have RA plus RB, vertical forces, and equal to downward forces. Downward forces are mg plus mg, 2mg, plus we have another force acting down, 3mg, because the wire will be pulled by these three forces. So RA plus RB, they are the same. So you can say that this is they are the same, RB equal to RA. So you can say this is R. So 2R is equal to 5 mg, 3 plus 2, and R is equal to 5 by 2 mg. This is value of R in terms of m and g. In terms of m and g, R. If you wish, you can write 2.5. 5 by 2 is 2.5. 2.5 mg. So it's your choice. The coefficient of friction between each ring and the wire is 4 by 5. The two rings A and B are on the point of sliding along the wire towards each other. Find the value of tangent beta. So we need to see the diagram to visualize the whole situation. This is the diagram. So they are saying the coefficient of friction between each ring is 4 by 5. The two rings are about to sliding down towards each other. That means they will be moving towards each other. So that will be the direction of motion. And why this towards each other, this statement is important because it will give us idea about the friction force, because they are about to move towards each other. That means on the wire, friction will be in opposite direction. So that will be the direction of friction, like this. So we need to find tangent beta. Now at that moment, what I'm doing is, instead of considering particle C, I am considering particle A. Or maybe B, it's my choice. So particle A. At particle A, the tension will be acting down. If I consider particle A, at particle A, the tension will be acting something like this. This is the direction of tension for particle A along the rope. Okay, so I'll just explain more. You remember, if you hang some object with a rope, like you have a roof, something like this, you have a roof here, and then you hang something, some object, just like, yeah, this is the string, and you hang some object. So this is W, mass of this object, W equal to mg. So if you consider this point of contact, So you say that tension is acting in upward direction. But if you consider the point at the roof, so you will say that tension will be acting in downward direction. So it depends which points we are considering. So in a previous part, we considered C. So I said that the tension is acting in the rope in upward direction, tilted, something like that, if you remember. Now I'm considering particle A or the ring A. So for ring A, tension will be acting in this direction. And now that means for T, I have component. For T, I have component. This is the vertical component acting down for particle point A, and then for this is the horizontal component, and this horizontal component will be acting rightward at point A. Clearly, you see that this is T cos of beta, and this will be T sine beta. But we need to consider particle A only. So we say that because they are a point of slipping or sliding, that means F is equal to T cos of beta. T cos of beta. And now, because we need to find value of tangent beta, so you can go back and you can see the part A where we got one equation of T sine beta with the equation, and if you recall, if you go back, and you will find the equation as 2T sine beta is equal to 3mg. This was the first equation, 3mg. Because we need to find tangent beta, so we have two equations. One equation in terms of sine, and the other equation we just figure out in terms of cos. So we divide these two equations to find tangent. So dividing 2t sine beta with t cos beta. So when you do that, you have 2t sine beta divided by t cos beta. T cos beta is equal to the right hand side of the first equation, which is 3mg, divided by the other side of this equation, which is f. Now clearly t and t gone, and you have a 2 sine beta over cos beta, this is tangent beta, is equal to 3mg and f. But we don't have f, we have coefficient of friction, which is mu. And we know that this is point of sliding, so F is equal to mu r. So you can say 3 mg divided by mu into r, and r was 2.5. I just substitute the value together, it will be good. Like mu, I can replace this mu. So F is equal to mu r, mu is 4 by 5. So 4 by 5 into r. R was 2.5 mg. So mg and mg gone, and you just simplify this, and when you just, again, I'm just leaving it for you, you rearrange and you simplify, and then tangent beta would be equal to 3 by 4. That's how you can find the value of tangent beta. I left step of simplifying for you guys. If you think that no, I should solve all this step, please let me know in the comments. So in next videos I can solve all the steps. Or if you're okay with that, then again let me know. Thank you very much for this. I hope you understand. See you in the next part. Have a nice day.